This is the 2020 MEXT Undergraduate Mathematics B paper. Let's begin. Section 1, Number 1. In this question, we are given this expression, and we need to find the largest natural number that is less than this expression. In order to solve this question, you need to know the change of base rule, which goes like this. Using this rule, we can express this statement in the following way. As you can see, the numerator of the nth term is the same as the denominator of the n plus 1th term. So we can cancel these out. So we are left with log base e of 2020 over log base e of 2. Now, we apply this rule backwards, and we get log base 2 of 2020. Now, 2 raised to the 10th power is 1024, and 2 raised to the 11th power is 2048, which tells us that log base 2 of 2020 is between 10 and 11, which means that the largest natural number that is less than log base 2 of 2020 is 10. So the answer is 10. Section 1, Number 2. In this question, we are given a function f of x equals 1 plus 1 over x minus 1, and we need to solve this equation, f of x equals f of x. What we need to do first is to rewrite this expression by combining these two terms into only one term. So f of x is x over x minus 1. Next, let's find f of x. So in place of x, put x over x minus 1. So let's simplify this expression. So f of x is equal to simply x. Then this equation becomes x over x minus 1 equals x. Let's multiply both sides by x minus 1. X is equal to 0 or 2. So the answer is 0 and 2. Section 1, Number 3. In this question, we are given a quartic equation, and the constant a and b are real numbers, and we are told that b is greater than or equal to 0. And this quartic equation has exactly two real solutions, and we have to find the minimum of a plus 2b and the maximum of the ceiling function a minus b. I will explain what the ceiling function is later. The most important piece of information that we are given in this question is the fact that this quartic equation has exactly two real solutions. So that means that the graph of this equation looks something like this. The graph touches the x-axis twice, like this. In order to solve this question, first of all, let's say that y is equal to x squared, so that we can express the quartic equation as a quadratic equation. If this quadratic equation has exactly one real solution, then the original quartic equation will have exactly two real solutions. When the discriminant of a quadratic equation is equal to 0, then the quadratic equation has only one real solution. B is the coefficient of y, so a squared minus 4 times a is the coefficient of x squared, so 1, and c, in this case, is b. So a squared minus 4b must equal 0. Therefore, b must be a squared over 4. And another thing that we know is that when we try to solve this quadratic equation using the quadratic formula, a is going to be preceded by the negative sign, and this whole part we assume to be 0, so y is going to be minus a over 2. But since y is x squared, x is going to be plus or minus root minus a over 2. This means that minus a over 2 must be positive, a must be negative. And now we can finally move on to this part of the question, finding the minimum value of a plus 2b. In order to find the minimum value, we need to differentiate this expression with respect to a. b is equal to a squared over 4, so we can replace b with a squared over 4. And now let's solve 1 plus a equals 0. This value of a satisfies the condition that a must be negative. When a is minus 1, what is the value of a plus 2b? Recall that a plus 2b is equal to a plus a squared over 2. And let's plug this number into a. So the minimum value of a plus 2b is minus 1/2. Minus 1/2. And now let's move on to the second part of the question, in which we need to find the maximum value of the ceiling function of a minus b. So what does this mean? Okay, so let's consider the expression a minus b, which can be expressed as a minus a squared over 4. To solve this question, it's going to be useful to draw a quick sketch. Let the vertical axis represent a minus b, and let the horizontal axis represent a. This is going to look like this. And this goes through the origin, and from the previous part, we know that a must be negative, so we must only consider this part. Since a cannot be equal to 0, the maximum value of a minus b is going to be a number that is as close to 0 as possible. So the ceiling function of a minus b must be 0. For example, the ceiling function of minus 0.0000000001 is 0. The maximum value of the ceiling function of a minus b is 0. Section 1, number 4. In this question, we are given that f of x mod x minus 1 squared is x plus 1, and f of x mod x squared is 2x plus 3, and we need to find f of x mod x squared times x minus 1. We don't know what the original function is, but from the fact that we are dividing this function by a squared number, we can infer that we are dealing with a cubic function, like this. So let's do some division. Assuming that this is f of x, let's divide this function by x squared. Now, the remainder of this division is cx plus d, but we know from this expression that the remainder is 2x plus 3. Therefore, c is 2 and d is 3. And next, let's use the first statement. X minus 1 squared is of course x squared minus 2x plus 1. So, what is ax times minus 2x? Minus 2ax squared. And what is ax times 1? Ax. B minus minus, which is plus 2ax squared. 2 minus ax plus 3. What is b plus 2a times minus 2x? Minus 2b plus 2ax. And what is b plus 2a times 1, b plus 2a. Let's simplify this expression. We know that the remainder of this division is x plus 1, so this is equal to x plus 1, meaning that this part is equal to 1, and this part is also equal to 1. 3a plus 2b plus 2 is 1, and minus 2a minus b plus 3 is 1. And we can solve these equations simultaneously. 3a plus b is minus 1, and minus 2a minus b is minus 2. And let's multiply both sides of the second equation by 2. So we are now solving this and this simultaneously. So plus minus a minus 5, a is 5, and let's substitute this value of a into this one. A is 5 and b is minus 8. Now that we know the coefficients of f of x, let's divide f of x by x squared times x minus 1. Minus 8 minus minus 5 is minus 3x squared. So the remainder is minus 3x squared plus 2x plus 3. Minus 3x squared plus 2x plus 3. Section 1, Question 5. So in this question, we have an angle which is between 0 and 90 degrees between these two straight lines, and we need to find the angle theta. Let's visualize this angle. Now, root 3 is about 1.7, so this is positive, whereas this is negative, and both these straight lines go through the origin. And let's call this number 1, and let's call this number 2. So number 1, number 2, and this is the angle theta. And we can use the following formula to find the angle theta. The formula says the dot product of vector A and vector B is equal to the magnitude of vector A times the magnitude of vector B times cosine theta, where theta is the angle between the two vectors. So let's express these two straight lines as vectors. Let's start with number 1. Starting from the origin, if we go 1 unit to the right, we are going 2 minus root 3 units above. So vector A can be expressed as 1, 2 minus root 3. Likewise, vector B is 1, root 3 minus 2. Now, what is the dot product of vector A and vector B? The dot product is the x component of vector A times the x component of vector B plus the y component of vector A times the y component of vector B. So 1 times 1 plus 2 minus root 3 times root 3 minus 2. 1 plus 2 times root 3 minus 4 minus 3 and plus 2 root 3 minus 6 plus 4 root 3. And next, what is the magnitude of vector A? Root the square of the x component plus the square of the y component. Likewise, the magnitude of vector B is... So these two vectors have the same magnitude. Let's rewrite it in terms of cosine theta. vector A dot vector B is minus 6 plus 4 root 3, the square of root 8 minus 4 root 3. So theta is inverse cosine of root 3 over 2, which is pi over 6, or 30 degrees. And this is the answer. Section 2. Let's read the first question. What is the probability that there exists a triangle with the side lengths root A, root B, and root C? In order for a triangle to exist, the following conditions must be satisfied. This basically tells us that the sum of two sides must be greater than the remaining side. But in this question, we are dealing with the square roots of A, B, and C. By squaring both sides, we get A plus 2 root AB plus B is greater than C. Let's consider the cases where no triangles can be formed. Let's say A and B are both 1. In this case, 1 plus 2 root 1 times 1 plus 1, 1 plus 2 plus 1, which is 4. So in order for a triangle to exist, C must be either 1, 2, or 3, because 4 is greater than 1, or 2, or 3. Therefore, there can be no triangles when 1, 1, 4, 1, 1, 5, 1, 1, 6. Next, let's consider the case A is 1 and B is 2. Now, root 2 is about 1.4, so this is roughly 3 plus 2.8, which is roughly 5.8. So when C is 6, no triangles can be formed. 1, 2, 6, 1, 6, 2. For the rest of the combinations, there will always be triangles. So 3 times 3 and plus 6. 9 plus 6 is 15. So there are 15 combinations of the values of A, B, and C where no triangles can be formed. And let's consider the denominator of the probability, 216. So P1 is 201 over 216. And this is the answer. Section 2, number 2. Given that there exists a right triangle with the side lengths root A, root B, and root C, what is the conditional probability that A, B, and C are mutually different? Given the fact that there exists a right triangle, from the Pythagorean theorem, we know that root A squared plus root B squared equals root C squared. So A plus B equals C. Likewise, when A and B are both 1, C is 2. And there are 3 permutations of these 3 values. That is 1, 2, 1 and 2, 1, 1. Next, 1, 2, 3. And there are 6 permutations of these 3 values. 1, 3, 4. 1, 4, 5. 1, 5, 6. 2. We cannot choose 1, so let's choose 2. We cannot choose 1 or 2, so this is the end. So let's add these numbers up. So given that there are 45 combinations of the values of A, B, and C, what is the probability that A, B, and C are mutually different? We need to exclude this, and this. 45 minus 9 over 45. 36 over 45. So P2 is 4 over 5. Section 2, number 3. When there exists a triangle with the side lengths root A, root B, and root C, and one of the angles is 60 degrees, what is M, which is the maximum value of BC over A? When we have a right triangle where one of the angles is 60 degrees, then the ratio of the sides is 1 to root 3 to 2. This is equal to root 1, root 3, and root 4. So in this question, we are considering the cases where one of the values is 1, and another value is 3, and the remaining number is 4. And there are 6 permutations of these values. And what is the maximum value of BC over A? BC over A is going to be maximum when A is 1, and B and C are 3 and 4. So the maximum value is 12, and this is the answer. Section 3. In this question, we are given two parametric equations, x equals theta minus sine theta, and y equals 1 minus cosine theta, where theta is between 0 and 2 pi. Question 1. Express dy dx in terms of theta. Dy dx can be expressed as dy d theta times d theta dx. So let's differentiate x with respect to theta. The derivative of sine theta is cosine theta, and let's differentiate y. The derivative of cosine theta is minus sine theta, but what we want is d theta dx, so we need the reciprocal of dx d theta. So dy dx is sine theta times 1 over 1 minus cosine theta. And this is the answer to number 1. Number 2. Find the area S of the figure A, which is bounded by C and the x-axis. Let's try to visualize the graph of these parametric equations. When theta is 0, x is 0, and y is also 0, because cosine of 0 is 1. So we know that the graph goes through the origin. When theta is pi, x is pi minus 0, because sine of pi is 0, and y is 1 minus cosine of pi, and cosine of pi is minus 1, so 1 plus 1, which is 2. So the graph goes through the point pi, 2. When theta is 2 pi, x is 2 pi, because sine of 2 pi is, again, 0. Y is 1 minus cosine 2 pi, which is 1, so 0. So the graph goes through the point 2 pi, 0. It's going to look like this. Therefore, the area that we need to find is the region here. Now the area S can be expressed as this integral between 0 and 2 pi. But because y is expressed in terms of theta, not x, we need to do something about dx here. We need to express dx in terms of d theta. Recall that dx d theta is 1 minus cosine theta. From this, we know that dx is 1 minus cosine theta d theta. We can replace dx here with 1 minus cosine theta d theta. Now, y is also 1 minus cosine theta. So, 1 minus cosine theta squared d theta. And let's expand the brackets. 1 minus 2 cosine theta plus cosine theta squared d theta. Now we know that the antiderivative of cosine theta is sine theta. What about the antiderivative of cosine theta squared? In order to figure this out, we need the following two trig identities. Sine theta squared is 1 minus cosine theta squared, and cosine 2 theta is cosine theta squared minus sine theta squared. So cosine 2 theta is cosine theta squared minus sine theta squared, and sine theta is 1 minus cosine theta squared minus 1 minus cosine theta squared. 2 cosine theta squared minus 1. So cosine theta squared is cosine 2 theta plus 1 over 2. So this can be rewritten as the integral of cosine 2 theta over 2 plus the integral of 1/2. Now, what is the antiderivative of cosine 2 theta? To figure this out, let u be equal to 2 theta, then du d theta is 2. Therefore, du is 2 d theta. Therefore, d theta is du over 2. Cosine 2 theta over 2 d theta is cosine u over 2 d theta, and d theta is equal to du over 2. So this is equal to cosine u over 4 du. Now we can finally perform the integration. 3 pi. So the area, S, is 3 pi. Number 3. Find the volume V of the solid formed by rotation of A in number 2 about the x-axis. Recall the formula for the volume, 1 minus cosine theta squared dx. And dx, if you recall, is 1 minus cosine theta d theta. So we have 1 minus cosine theta cubed d theta. So let's expand these brackets. The formula is a cubed minus 3a squared b plus 3ab squared minus b cubed. 1 minus cosine theta cubed is... From the previous question, we know that cosine theta squared is cosine 2 theta over 2 plus 1/2. Now, what is cosine theta cubed? Cosine theta cubed is cosine theta squared times cosine theta. And recall that cosine theta squared is 1 minus sine theta squared. Now let u be equal to sine theta. Therefore, du d theta is cosine theta. So du is cosine theta d theta. So now we have cosine theta d theta here. This can be replaced with du. So cosine theta cubed d theta is cosine theta d theta minus u squared du. So let us now integrate. Recall that cosine 2 theta over 2 d theta is sine 2 theta over 4. So minus I forgot to add pi at the beginning. U was sine theta, so 2 pi cubed over 3 minus sine 0 cubed over 3. Sine 2 pi is 0 and sine 0 is 0. So this is going to be 0. So what are we left with? 2 pi plus 3 pi. Pi times 5 pi, which is 5 pi squared. So the answer is 5 pi squared. And this is the end of this exam paper. If you have any questions, please let me know in the comment section, and see you next time.